Hi, this is Bradley Bush. Today we're talking about scientific notation, which is a topic used in a lot of mathematics, but you find it in algebra. Short answer, scientific notation is really a scary looking thing, but it's actually very simple. Scientific notation is simply an abbreviated form or a shorthand for a very large or a very small number. That's it. That's really it. So let's give you just a definition. Here we have a more mathematical definition. So if a number is written of the form c times 10 to the n, so this little x here is not actually an x, it's actually a multiplication symbol. So, and c is just any real number. So c can be anything. It can be 2, it can be 1.5, it can be negative 3.6. As long as it's a real number, it's okay. So if it's written in this form, so c, some real number, times, and they do use the x for times instead of the dot conventionally. There's no reason, that's how the notation is. So c times 10 to the n, and n must be an integer. And if you're wondering what in the world is an integer, you can look at my video on the real numbers, or you can look down here at the note. Integers are numbers in this group. So the dots on either side mean go on forever to the left and to the right. So you would think of an integer as something without a decimal. Negative 10, negative 3, 1, 6, 9. So n must be an integer. N being this exponent on the 10. So as long as the number is written in this form, then it's in scientific notation. There's only one little caveat that I think I'll add to my claim that as long as it's written in this form, it's in scientific notation, and that is that c, which is the number right here, the constant, the real number, it has to represent the first few non-zero digits in the number. And I'll show you more as we go down and do some examples. So here's some examples. Oh, and I forgot to mention also this little piece of information. The absolute value of c must be bigger than or equal to 1 and less than 10. So let's look at some examples of scientific notation. So it sounds kind of crazy, but literally once you see a few examples, you're going to think, wow, that is really useful and is not as scary as you might think. So let's take example 1. And we have a very large number here. We have 9 zeros. So we have 49106, and then we have 9 zeros following that. So it's kind of a big number. So if we wanted to write it in a smaller, more concise form, then what we could do is we could say, well, what if we rewrote this as we find the first non-zero digit, and we're like, hey, let's put a decimal to the right of that first non-zero digit. And off we go. So this part right there is right here. This is your value for c. And we have the multiplication here, the times, and then we have 10 to a power. And that power, that's our n. So is the absolute value of c less than or equal to 1 and less than 10? I think it is, because if we take 4.9106, absolute value less than or equal to 1, less than 10, that holds, because the absolute value of 4.9106 is just 4.9106. So that's true, and 13 is in fact an integer. So that's scientific notation. So if you didn't want to write this big thing, you could just write this, which is more concise, and you don't really lose any information for this one. So let's do example 2. I'm not going to go through all of these steps for examples 2, 3, and 4, but now that you've got the hang of it, I think you'll catch on. So in example 2, we have a lot of zeros right here, right? And then we have a 5, 2, 1. So if we don't want to write it with all those zeros, we could just say, well, the first non-zero digit is the 5, and take this portion, the 5.21, and it's negative. And here we have our C, and we have our multiplication x, and 10 to the negative 15. So you might wonder, where does this negative 15 and that 13 come from? Well, if you look back on example 1, if you take, I'm going to start and get rid of the blue. If you start right here at where we want to place the 0, and then you count all the way over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 13 of those. So over to the right, if you took this decimal and you went 1, 2, 3, 13 places, you would get the number on the left. So the 13, the n, the exponent on the 10, really tells you where to place, where the decimal really should be. If it's positive, which 13 is, then you really should be moving the the decimal right there, 13 to the right in the real number, not the scientific notation number. And if you have a negative, like you do in example 2, negative 15, that means that this decimal here in the negative 5.21, that negative really, in normal notations, should be 15 to the left, 15 decimal places. So it's pretty slick, actually. Let's look at example 3. We have negative 62 million. So we're like, hey, that's kind of a lot of zeros. So let's put the decimal right after the first non-zero digit and convert it. So this becomes negative 6.2. This is our C. We have our times. We have 10 to the n. 7 is the n. So in other words, the real version of the scientific number, if you took this decimal and you went 1, 2, 3, 7 times, 7 to the right, you would get back to the original. And example 4, we have a lot of zeros here. Not as many as the previous example, but it still can be written concisely. So let's put the decimal right after, to the right again, of the first non-zero digit. And notice from here, you go 1, 2, 3, 4, 4 to the left. So that's why we have a negative 4 here in the exponent, and the 3.18 is our C value, and of course we have our times. So the 10 to the exponent really just moves the decimal left and right. The 10 to the exponent, 10 to the negative 4 moves the decimal 4 to the left. 10 to the 7 moves the decimal 7 to the right. That's all the 10, the multiplication by the 10 is. So if you have interest in how to convert from, more examples on how to convert from scientific to decimal notation. Decimal is the normal notation. Decimal right here is what you would normally see, the normal notation. Then please check out my YouTube channel. I've got some where I convert from scientific to decimal and decimal back to scientific. If you have questions, let me know. Thanks for watching.